Hello, good afternoon. This is Abdullah Al-Amin, Elizabeth Creak Fellow at Harper Adams University and visiting scholar at Purdue University, United States. In addition, I work for Bangladesh Agricultural University as an assistant professor. Me, together with Professor James Lowenberg, who is the co-editor of Precision Agriculture Journal, and Elizabeth Creak Professor at Harper Adams University. Kit Franklin, principal investigator of the hands-free hectare projects, and Elizabeth Creek Professor Karl with Professor Bruce Erickson and John Evans from Purdue University, United States, have been doing research on economics of strip cropping with autonomous machines in the context of Indiana, United States, using the experience of the hands-free hectare demonstration projects. Over the 20th century, United States crop production have been transferred towards consolidation of acreage and production, whereas the large-scale conventional mechanized farms highly focused on monocultural mindset owing to economic incentives, for example, labor productivity and economies of size. Whole field conventional farming can create environmental risk, accelerate the loss of soil health, GHG emissions, and disturbance of ecosystem services. The conventional whole field farming were unable to reconcile land productivity and biodiversity gains to meet the increasing future food demand while mitigating the ecological footprint in agriculture. Sustainable intensification solution is crucial in agriculture. In this backdrop, autonomous mixed cropping systems are hypothesized to facilitate the agroecological farming. Autonomous regenerative agriculture. Throughout the world, agroecology innovators suggested many mixed cropping options, for instance, pixel cropping, patch cropping, and strip cropping. However, differences in plant height and growth patterns proving to be an engineering challenge in automating regenerative agricultural practices. For example, pixel cropping in Netherlands mentioned this type of technical challenges of farm management. In this ground, regenerative strip cropping is expected to be the simplest technically feasible mixed cropping systems. State of the art of strip cropping and limitations. Existing empirical research in large-scale farming, for example, United States, Argentina, and medium-scale farming in the European Union and small-scale farming in China showed the agronomic and biodiversity benefit of strip cropping. The economic studies on strip cropping mainly used partial budgeting to examine the comparative productivity and profitability. And the most updated study conducted by Ward and his colleagues, they showed that strip cropping provides greater gross receipts over monocultural corn and soybean, but machinery ownership and higher level requirement results in lower net returns. And they hypothesized that the advent of new technology, for example, autonomous robots, will mitigate the labor problem and alter the cost calculus of strip cropping with higher yield potentials. To fill the research gap, the objective of the study was to assess the economics of strip cropping with autonomous machines compared to whole field conventional farming. And the study hypothesized that autonomous machines would make strip cropping more profitable than conventional whole field farming and thereby facilitate the regenerative agroecological farming. To achieve the objective of the study updated the Ward and his colleagues' analysis considering the autonomous scenarios of the hands-free hectare machines and the current prices and agronomic practices for central Indiana in United States. Corn soybean production and cost are collected from Purdue budget. Land constraint data are collected from Ward and his colleagues' study. Following Ward and his colleagues, the strip width was considered for 15 feet with 76 centimeter rows. And the machine inventory and list pricing data were collected from John Dree and McKay's IS for further validation. The study collected the list pricing from different equipment websites like ST Joseph Equipment, Fast Line Equipment, Equipment Trade, and Machine PT and Tractor House, and so on. In modeling purposes, the study used the Hans Reactor linear programming model, which was adapted from Purdue crop livestock, usually known as PCLP model, that was widely used throughout the world, like the United States, Brazil, Colombia, Thailand, and various African countries. In our modeling, we used land, human labor, and equipment times as constraints. The results of the initial analysis revealed that stick cropping with autonomous machines was profitable over conventional whole field farming and the conventional stick cropping practices for small conventional machines like 50 horsepower tractor. And for robotic operations, we use the 50 horsepower tractor, which was retrofitted for autonomy, considering the Hans reactor experience. And we use the experience to test the feasibility with the lens of ex-ante analysis. The conventional stick cropping farming uh, showed lower gross margin, and that may be due to the higher level requirement for the conventional small machines for stick cropping. The results of the return to operator management and risk taking was higher for stick cropping with autonomous systems. Unlike Ward and his colleagues' study, the return to operator management and risk taking was higher for conventional stick cropping, and this may be due to the recent increase in the price of large equipment and changes in the corn and soybean price ratios. Even though the study contributed to the precision agriculture and agroecology regenerative farming practices, there were limitations in the initial study because the study only considered the large-scale farm in central Indiana, United States, whether there is enough room to incorporate different farm sizes to get the economies of size issues. Future research will address the working day lengths for sensitivity test. For instance, the present study considered 10 hours for conventional and 22 hours for robots, that is the autonomous machines. But there is enough scope to test what will happen if the conventional larger machines can operate for 22 hours, because these machines are really um, comfortable to run for such longer hours with the advent of modern facilities. And future research will address different corn and soybean price ratios in sensitivity test and good field days for investigating the implications of climate change. And in future research, we again add the scenarios in sensitivity test. What will happen if we consider different yield penalties in the headlands because we consider continuous soybean in the headlands, considering the technical issues of strip cropping. And the future research could mitigate the research gap on precision conservation literature to empirically examine the economics of precision conservation, and because the existing model can be extended with different scenarios considering the ecological lens like page strip in the fields, field enclosures like wetlands, hedgerows, and different field margins to get the sense of both economic and environmental gains through the precision conservation issues. Considering the trade-offs between conventional whole field farming and environmental gains, the study reached in the following conclusions. The profitability of strip cropping with autonomous machines indicate the potential of strip cropping for regenerative agroecological farming. Autonomous strip cropping systems reconcile both economic and environmental goals of farming through limiting the ecological footprint, and the autonomous machines will diminish the labor scarcity problem in agriculture as the world is facing the labor scarcity problem in agriculture. Thanks for your patience hearing. Please feel free to raise questions.